Hi, everyone. Thank you for joining. Happy Thursday. My name is Sue Ewig, and we are so excited to present today's webinar, which is covering Amazon SageMaker Ground Truth. Our presenter today is Chaitanya Hazare, and you have heard from Chaitanya before. He's one of the machine learning focused PSAs on the AWS partner team, and he's going to do a deep dive for you today on Ground Truth. This webinar was originally scheduled for last month. Actually, it might have been the end of May. And we pushed it out because of a conflict, and I'm somewhat glad we did because it looks like we have tons of interest in this topic. So I'm very glad that all of you were able to attend today. And I know we've got a lot of folks who will be listening to the recording who couldn't attend at this particular time, so welcome. Also on the call today, we have Chris Burns. You've heard from Chris as well. He's a senior partner solution architect with an AI/ML specialty. He will be answering your questions. So in the right navigation on the GoToWebinar control panel, you'll see a question pane. And please, during the webinar, just feel free to pop your questions in there. We will either answer those questions in that pane, or we will talk through them live between Chris and Chaitanya at some point during the call where it makes sense. If we don't get through all the questions, we will send out an email to everybody at the end summarizing everything that we didn't get to. But without further ado, I'm going to go ahead and hand it over to Chaitanya.
Thank you, Sue, and thank you, Chris, for moderating this. Hi, everyone. Good morning, good afternoon, or good evening, depending on where you are tuning in from today. Thanks for being here today for our deep dive webinar about Amazon SageMaker Ground Truth. I am Chaitanya Hazare, Partner Solutions Architect with AWS, specializing in machine learning. So today's topic is building integrations with Amazon SageMaker Truth. Or, if Sue would allow me, sorry, this would be my label. This would be my topic. Researching for this webinar was a bit interesting. I decided to approach this topic in an atypical manner and made sure to include at least some content that is not covered by other talks on this topic already. We label things as we see them. This is of particular importance in the field of machine learning. Amazon SageMaker Ground Truth, which we released at reInvent near the end of November 2018, basically is a service that helps our customer label their data accurately and efficiently. Let's start with the basics. What is data labeling? Typically, you would want to label a good amount of data to bootstrap your machine learning project. When you have a business problem to solve, the typical machine learning process starts with ML problem framing and then data collection integration, followed by prep and clean. When you want to solve new business problems, break new ground in which supervised machine learning techniques might be useful, but you do not have a good amount of labeled data to be used. You start with labeling your data and then training a machine learning classifier. Here are some use cases in which we improve the accuracy of machine learning models by augmenting the data by providing more labeled data. We have augment data with more labeled data, or in some cases break new ground and solve new problems with machine learning techniques. For instance, text analysis. We have a customer, T-Mobile, that uses ground truth to analyze intents from their customers. When their customers call into their call centers, they take their initial statements and classify it as intent. Intent is the start of the state machine of a typical conversational AI agent. A customer may want to change their billing address, or they might have a question on their bill. Here we are using data labeling to train a model that can identify those intents automatically. Another use case is precision agriculture. In this use case, you want to train a model to understand crops and weeds in a given image. Red boxes identify the weeds and the green boxes identify the crops. Yet another use case we see is in food safety, where you want to identify objects in a kitchen environment. Excuse me. Self-driving cars is yet another area where we have seen a lot of these use cases of high fidelity labels, high accuracy labels, because the computer vision systems for self-driving cars are dependent on this kind of very highly accurate label data to identify everything from stop signs or pedestrians or other vehicles on the road. Finally, there is inventory cataloging. There are scenarios where basically you have a large number of inventory items that you want to be able to essentially identify them automatically in an image or in a video frame. These are just some kind of use cases that we are seeing many of our customers use. Very briefly, in a supervised learning algorithm, in this particular use case, where we see a convolutional neural network architecture for image classification, the algorithm would learn from a training set of input and output pairs, basically labeled pairs. Would learn from a training set to understand different classes of images it's being exposed to. Here, internally, the algorithm learns through repeated exposure to label data. After being trained, until a particular accuracy has been achieved, it understands how to correctly classify a new image when it is exposed to it. These labels and classes are typically provided by humans. It's tremendously powerful and converges on its own once you give it these two critical inputs: the raw data and the labels. This is why labeling has become such a critical need for many of our customers. Why? Well, then why is data labeling difficult? So, what makes data labeling difficult, as it is with most cases, scale hurts. The main variable that we optimize here is classification accuracy. Classification accuracy is a measure of how well a machine learning classical classification machine learning algorithm is faring. It is the ratio of number of correct predictions to the total number of input samples. To attain a good classification accuracy, you have to provide an algorithm. You have to provide the algorithm with a lot of label data to learn from, or in other words, train on. To get started, to get a lot of label data, we need to do a lot. We have to employ a lot of people to label the data. People, humans, just like you and me, are individual actors. They have individual biases and propensity to errors. When you have a large number of humans performing these labeling tasks, you need to build in a lot of controls and checks to make sure that label data you are generating is accurate. As we have found out during our frequent interactions with our customers, that this would end up taking as much as 80% of customers' time. As the labeling of the data set becomes more and more complex, these complications become more acute. Here you see a very advanced form of labeling. This is called semantic segmentation. Semantic segmentation describes the process of associating each pixel of an image with a class label. Here, it is about people, road, car, building, electric poles, and so on. Self-driving cars typically need to have this high precision detection of objects, as you know exactly where other cars are in relation to your car, where all the human beings are in relation to your car. This is a very high precision activity and justifiably involves a lot of human effort. Without any automation, this could lead to a lot of wasted efforts and inferior models. This is where Amazon Ground Truth comes in. Before zooming in on Ground Truth, let's take a holistic view of what SageMaker provides. So Amazon SageMaker provides every developer and data scientist with the ability to build, train, and deploy machine learning models quickly. Amazon SageMaker is a fully managed service that covers the entire machine learning workflow to label and prepare your data, choose an algorithm, train the model, tune and optimize it for deployment, make predictions, and take actions. Your models get to production faster with much less effort and lower costs. You have hosted notebooks, and you can pull off the shelf one of these built-in high-performance algorithms that SageMaker provides. You can use one of these algorithms, or you can bring your own algorithm and perform one-click training. We provide a number of features that help you optimize training. For example, we provide automated model tuning, or that's called hyperparameter optimization, that essentially allows you to optimize algorithm hyperparameters. It's a challenging space to search. Once your model is trained, it's very easy to deploy. We have one-click deployment. Finally, once your models are deployed, there is automation in terms of auto-scaling of your deployed endpoints. We have extended this toolkit and tightly integrated Ground Truth to now provide you a labeling capability that works really nicely across the board with all other functionalities of SageMaker. So Ground Truth has a tight integration with SageMaker, and that was a very important aspect of this service. But we wanted to go beyond and help our customers address some of the critical pain points with data labeling, provide those controls and checks to ensure the accuracy of label data that we referred to earlier. More data equals more accurate models, and more data in the context of supervising learning almost always means more label data. There is tremendous opportunity here to help customers save some of the costs associated with data labeling, as well as to speed up the data labeling process. In many cases, we heard that it's not only occupying 80% of the effort, but it's also slowing down our customers' machine learning initiatives considerably. I want to now delve deep into the key features of Amazon Ground Truth. The core feature and the core functionality we have introduced in SageMaker is for you to be able to create a data labeling job. There are three things that make up a data labeling job. First, there is the input data set that you provide. be they images or text objects. Second, there is the actual work definition, the labeling job that is going to be distributed amongst the workforce. So in these cases, we saw like bounding boxes, or we saw the dog classification labeling images, or in the T-Mobile use case, intents. Third, then there is the workforce or the human beings that are actually going to perform the labeling. Well, as with everything else, there is a lot of choice here. You have multiple options. When you're kicking off a data labeling job, and we'll check this out in the demo later on, you have brought in your input data set and you define the labeling task now. And you can choose from a multiple workforce options. The first is the public Mechanical Turk cloud, and it's basically Mechanical Turk crowd, excuse me, and basically an on-demand 24/7 available scalable crowd that works on task by task basis. You are actually working with Mechanical Turk through your ground truth, right? So, and this is directly built to your AWS bill. We are kind of intermediating that relationship for you. Now, the private cloud, you can bring in your own workers. That means, what that means is we are actually hosting a labeling application for your team, and it's a entirely separate labeling application. The identity infrastructure is managed by Amazon Cognito, which is a separate AWS service. So you can integrate this into your authentication mechanism. This is and so you could onboard workers onto this application as per conventions of your work environments. This is quite handy for very specialized workforce where subject matter experts are at hand, or like you're breaking new ground, or there are sensitive tasks, or testing new data set for labeling. Then thirdly, we support a curated set of vendors. These vendors are listed on the AWS marketplace, and they set their own rates, and you contract a new contract with them directly through AWS marketplace. And then you can use them in the context of ground truth workflows. These are the supported data labeling tasks for which we have pre-built templates, and it's what's special about pre-built templates. I'll come to that in a bit. In addition to custom tasks, we support object detection with bounding boxes. We support semantic segmentation. We support image classification. For text, we support text classification to kind of describe each of these. In the bounding boxes piece, essentially you are identified spatially where the objects of interest are in a particular image. Image classification can be binary or multi-class classification. So in this picture, for example, you see two options, basketball or soccer. You could say that it could be a number of choices provided if this is a basketball game or soccer game or a football game, etc. Image semantic segmentation is what we discussed in the context of pixel level labeling, so that you can see the car colored blue and the individual colored red here. Moving on to text classification, you can provide us with a blob of text, and basically what you see here is you can categorize the text in one of several different classes. Sentiment analysis being one of the most important, one of the most used labels. In this case, there are specific examples you see. Then finally, you have custom tasks. This is the demo that I want to cover towards the end. Hopefully we have time for it. Where you can essentially provide your own HTML for the UI. You can also use higher level liquid templating language to create these tasks. And you can insert your logic before or after the task is shown to the worker. What lends custom tasks even more flexibility and dexterity are the custom lambdas. We'll take a look at this during our demo. An amazing blog has just dropped, and that like takes you through the workflow, and this dropped like 2 days back. So good that we postponed this talk. So there would be two lambdas involved. One is involved after the labeling job. In the example, it is called annotation consolidation lambda for custom labeling jobs. It takes all the worker responses for the item to be labeled and output a consolidated annotation. Then there is one job that is invoked before the labeling job. Amazon SageMaker invokes this lambda for each item to be labeled. Output of this lambda is merged with the specified custom UI template. All these given to you, all these give to a lot of flexibility in terms of types of tasks and the types of workflows you can create. So let's get on to the one of the most interesting bits, at least according to me. Let's talk about the science behind the ground truth for a bit. How are we improving the accuracy and efficiency of data labeling? We continue to innovate behind the scenes, making the services better. These features that I point out to you now are quite critical when generating large data sets. We are talking about millions of images that are accurate and dependable. Now, there are features that build on top of the data labeling job. These are the automated data labeling and high accuracy labeling. What happens in automated data labeling is that it will learn about your data, make a decision as to which ones can be automatically labeled and about which ones a human should be involved. So I have an example for this as well later on. This is an opt-in feature, and we do not turn this on by default. What happens here is that we train a model using SageMaker on your data right there in your account. You can even use this model afterwards. This is a neat feature and exploit the duplication in data set quite well. You do not want to send all the data to be labeled by a human being. That would mean a lot of wasted effort and resources. But you want to be very selective about what is being sent and how many times. Um, Now let's talk about other feature on top of the data labeling job, high accuracy labeling. This primarily applies to those pre-built templates I was referring to earlier: semantic segmentation, multi-class labeling, and so on. These are the tasks that we understand well. We continuously improve upon these and provide you with a well-designed, researched, and a vetted UI template that is also used internally at Amazon. We also know how to improve accuracy levels of these kinds of jobs. These templates, their presentation and internal implementations are based on research and kind of best practices that we have seen in-house at Amazon. I'm sorry, I missed playing the animation there. Okay. uh, So in the backend implementation, we use an actively researched practice called annotation consolidation. Annotation consolidation combines the annotations of two or more workers into a single label for your data objects. An annotation is a result of a single worker. Annotation consolidation combines multiple annotations from different workers to come up with a probabilistic estimate of what the true label should be. The label is assigned to each object in the dataset. Each object in the dataset typically has multiple annotations, but only one label or a set of labels. You can decide how many workers should annotate each object in your dataset, and then the annotation consolidation kicks in automatically. More workers can increase the accuracy of labels, but also increases the cost of labeling. Using all these techniques, that's how we really drive very, very significant decreases in the amount of human labeling that needs to be performed. We have seen kind of decreases in the ballpark of up to 70%. Substantial reductions in the amount of data that needs to be manually labeled. Once you bring a data set, a couple of things to call out. Uh, you will get a fully labeled data set at the very end. You'll know what is human labeled versus what is machine labeled. You will also have visibility in the output data set. Since we are training those machine learning models in your account, all the artifacts, like the model artifacts, are available for you later on as well. In fact, when you enable automatic data labeling, you can also get a trained machine learning model that you can use as you wish. If you enable automatic data labeling on for bounding boxes, we are using the um, SSD SageMaker built-in algorithm. We have seen tremendous results with this feature, and we are very excited for this feature. Just to reiterate, this is something that is opt-in feature, and we do not enable this automatically. Finally, before we jump into the demo, let's talk a little bit about pricing. You pay for each labeled object, whether it is labeled automatically by ground truth or by human labeler. If you use vendor or mechanical turk to provide labels, you pay an additional cost per labeled object. If you use your employees for labeling, there is no additional cost per labeled object. That page that I pointed out has a very, very detailed and up-to-date breakdown of pricing options with multiple scenarios that they run by you. Please do check it out. Now, let's jump into a bit of the messy part of this whole demo, whole webinar. Let's take a look at the AWS console. I'll try to minimize my window switching so everyone can follow easily. Okay, so let's start with the very basics first, and then I'll jump into then I'll show a detailed demo that I've recorded already. Usually, Amazon ground truth demos take a little bit of time to be to complete, so I opted in for recording these. So how to access Amazon SageMaker ground truth? You want to go to Amazon SageMaker, and in that you want to get to ground truth labeling jobs. So I have a couple that I have executed over the weekend and over the past week. Um, you start your workflow by creating a labeling job. You name the labeling job. Then you give a manifest. Now this manifest is nothing but a one-to-one mapping of the file name and the file location. SageMaker Ground Truth has a crawler that can create this for you automatically. And the blog that I want to point out actually has all these examples, all these details in it. So I would love for you to check that out. I'll leave that there for a bit and switch back. Output dataset location. This is where you get the labels and you get separation of your data. You can select any type of job, and then you can say next, and basically the execution will start. Uh, I will take this moment to go and start the recording while I walk you through it about a custom labeling job that I created over the weekend. So the beginning of the custom created job is, sorry, give me 1 second. Okay. Is you start off by installing, remember those two Lambda functions. So you go to the serverless marketplace repo, serverless application repository, and get those two Lambdas deployed in your account. Once you deploy them, we'll make a note of taking a look at it. Once you deploy them, you can check them out in the Lambda console later on. So there is not much that you need to do here. These are the names. So when you want to search for it, these are the names that you would search for it. And then you go ahead and of course there are more complicated workflows here, but we are just covering the most basic workflows. Once you click deploy, I believe you can go and check out in the Lambda console for them. Using the Lambda console, you can tag it, you can change the code, you can add code to it, you can change the permissions, and you can basically it's a very malleable piece of software that you can use. So this is after it has been successfully deployed. Remember that these are two lambdas, pre and post. So pre lambda is invoked per every image, and the post lambda is invoked once the annotation has been performed. So using this console, you can monitor it, you can check the invocations, and you can see the logs in CloudWatch. That's what is being shown here. For some reason, my laptop during recording this, maybe it was overwhelmed because of the recording software, and it was running very slow. So please bear with this. Try to go out a bit. So this is after I have kickstarted a custom labeling job, and these are the invocations of those lambdas basically. The execution path of this demo might be a bit weird, wherein we are starting. I'm trying to follow the blog faithfully so that you have a very solid reference to go back to. And there is one thing that I got wrong like a couple of times, and I'll point to that too later. So basically, you can go to the CloudWatch and follow the logs of your Lambda invocations. This is me following the logs. What I'll do is I'll upload these videos, the demo videos, hopefully in a repo, and publish it as well, so you can have access to it later on. Then the second step in the blog is to create a custom labeling job. That's what we are going to kick off now. So what I've done is, this is like a data set that took, I think, took me like 30 minutes to download. So I downloaded it, and as the blog says, upload a section of those images onto S3. I did that. So I created a bucket, created a folder in the bucket, data sets, put images in there. So these are the images. Now remember the manifest. So the as if you point Amazon SageMaker ground truth to this bucket, it will automatically create the manifest for you. So this is me creating a custom labeling job. Of course, you can choose whatever name you want. Uh, then you ask it to create a manifest file by giving this. So the manifest file will be generated automatically. Uh, this is where I want to like point out one thing that might be a bit tricky. You create a execution role here. Um, please write this down somewhere else, because what you want to do is, for the annotation lambda to work, you want to create a trust relationship between this and the lambda IAM role, and I'll cover that later on in the second recording. So here we create the custom flow. I am using public workforce. Um, this is the liquid modeling language that we talked about before. Once you set this up, so this is custom, and then you set up the pre and post lambdas. You select them. Again, this is you search for them using the strings that we showed in the Lambda console. One step that is missing here, which I think got skipped over, is once you do this, you can preview it as well. So when you preview it, you actually see how it is going to look for the human labeler, and you can actually try and then debug it, and then figure out if that is what you want, and fine tune it a bit. This is me trying to figure out the trust relationship. So I'll move on to the next video where I figure it out and do it. So this is the Amazon SageMaker execution role that you have created before. And this is where you want to set up the trust relationship. So two things that the blog goes into: you have to set up the trust relationship, and you want to attach a policy that will allow AWS Lambda full access. Um, I will now, excuse me. So we created that. How does it look once it is completed? So this was the job, and these are street scenarios. And because it's a high complexity task, everything was human annotated. I have a different example where we can see, oops, sorry. that a few things have been machine annotated as well. So your input data set is here, your output data set is here. What there are a few sample notebooks in AWS samples. What they do is they do a data analysis of how your ground truth task has performed. And one of the really neat things that they would give you is they generate a PDF, but one of them generates a PDF that is labeled data analysis. The second one gives you this neat graph where you can see the human annotation and the machine annotation kicking in. Like you can see active learning happening here. So I'll upload this notebook as well. So to analyze the data that is in your output bucket, you want to use these two notebooks to understand what exactly is happening. And the final piece is this is Amazon Ground Truth benchmark that you will get from the first notebook that I showed. It will be okay. What has been annotated as food by machines, uh, cheetah by humans. So there are a few errors as well in there. Cheetah by machines and so on. So I would encourage you to try out those toy examples to learn more about the service. And I will hand it over to Sue and Chris. Oh, one last thing. So those lambdas, they are available as, and again, the blog goes into depth. The code is available here that you can check out and basically customize as per your requirements. I'll now hand it over to Sue and Chris for any questions if you're there.
Hey, Chaitanya. Can everybody hear me? There aren't actually any questions. There was just a great question earlier asking for the URL of the blog, and Chris Burns posted that for everybody. So if you were looking for that, folks, it's in the Q&A portion of the right navigation. So that's it. We are on track and good to go. So if that's it for today, if nobody has any other questions that they want to pop in here, we will go ahead and close this out. Chaitanya, you killed. Here's another question real quick, sharing the deck or the recording. And yes, the recording will be shared in about 5 to 6 hours. You'll get an email from GoToWebinar that will give you a link to the recording. So everybody gets that, whether they attended today or they just registered. So you can go back and kind of sift through some of the content. There's so much great information here. Also, when I close out the webinar, there will be just a couple questions that pop up, three whole questions, and would appreciate it if you could answer those.
Okay.
And that's it. We have another one in 2 weeks. So hope to see you guys all then. Chaitanya, did you have something else to add?
I see a bunch of things coming here. So maybe we can follow up. I just want to say thank you. First of all, thank you to Sue and Chris for helping me out and let me do this. And thank you for everyone for attending. And we'll make sure that my whole team follows up with the questions. And Chris, if you would like to answer, get to any questions, I'm having a difficult time popping up the pane.
Yeah, no problem. So Chaitanya, you did a fantastic job with the presentation and the explanation. Very easy to follow, very informative, and I think that contributed to the lack of questions. We had a couple questions basically about URLs and if this material will be shared after, which of course it would. There's one in here about they'd like to see what the human annotator sees. So my suggestion to you there is to go ahead, Chaitanya. Go ahead if you want to take that.
No, please go ahead. I'll see if I can pull that up. Please go ahead, Chris.
I was going to say that for as far as human annotator goes, you're obviously welcome to jump into the console to see what the data scientist role sees. But as far as if you're looking for the mechanical Turk style view. I don't know that we can share that, unless Chaitanya, you know differently.
Yeah, we can. I'm sorry to go there, Chris. So
That's okay.
basically, the way you do it, I'll see if I can do it quickly. Let me try that, please. So you do this, then you do custom job, next, okay, public, yes, yes. Now let's see if the magic happens. Okay, and then you have to put these in. That's like a tricky thing that I figured out the hard way. And you do preview. So this is me. I had created a job called Jeans and Food, and then you draw, like basically you can draw a stroke add instance person. I want to say this is a person and submit, and hopefully, so basically it should get me a different one, a different. So this is what the human being sees, and you can go and optimize this and fine tune it using the liquid language that goes here. So that does that hopefully that answers the question.
I think it did.
Over
I think
to
it
you.
did. Yeah. And let me see here. I'm trying to couple questions in here that we could probably follow up on afterwards. A little bit of a tangent. Some accolades for you here, Chaitanya.
Thank you.
Somebody asking about sentiment analysis on SageMaker. Yes, you can. You could also use Amazon Comprehend. It's a service dedicated to sentiment analysis. Or you can spin up your own algorithms and your own training model, train your own models on SageMaker. Here's an interesting one. Do we know about fulfillment cycles? So I guess they're asking time span for labeling, say, 100K images. Well, let me rephrase, 100K samples. They don't have to be images.
Yeah, I do not know. That's why what I did is, well, I don't know how to quantify it. I do not know is the wrong answer. I don't know how to quantify it. Maybe if you pay more, like there is an option to pay more, maybe you get it quicker back. But what I did is, I don't know if I can show this right now. It'll be like legible. This guy I kicked off like 10, like yesterday night, 10 11 p.m. or a day before that, and this maybe, so I can then track here. Or let's see if I can. I'm sorry, there is a bit of messing. So see, there is a person annotating it. Can you see this, Chris? Can you see this?
Yep. Yeah, we can see.
Okay. So so all this is available in the output bucket. What you can do is you can, I don't know, create import it in QuickSight, a really amazing visualization tool, and see when the last label was created. But I can see that goes around all sorts of times. And by the way, this is I try, because I wanted to get this done. I actually selected a very highly paid workforce, like Amazon Mechanical Turk workforce, but I paid maybe $1 or something for each image. That's not a full answer, but that is the answer that I have right now. I can follow up. We can follow up.
Yeah, sure. We can follow up with some of these questions with more comprehensive and quantifiable answers.
All right, sounds good. Yeah, we can just export this and answer these questions and then send that out. That's easy enough. So thanks everybody for hanging in with us today. It was a nice, quick and succinct but deep learning on ground truth, and hope to see you guys in a couple of weeks on the next webinar. I'm going to go ahead and close it out now and hope everybody has a great day. Thank you.